enter the well, add the sample slowly. It will sink nicely to the bottom, displacing the liquid within the well. When you reach the first stop, you keep it compressed, wait a few seconds for the sample to move away, and then you withdraw. Now we're going to show you a couple of examples of what not to do when you do a gel load. And now we're going to go into the well, and instead of adding slowly, we'll add rapidly, meaning all the other wells. Now we're going to see when we load a sample, if we go too far down into the well, we end up piercing the bottom. And you may not realize this when you're at the bottom and you try and add the sample, you compress, nothing happens because the orifice is blocked, but then you move out and the thing just explodes into the well. And you end up again with cross-contamination and loss of sample through the puncture. So now we're going to load a sample showing you another error that can happen. So I'm stabilized into the well and I go down to the first stage, and usually you're supposed to stay there and withdraw, and sometimes people forget and they release the piston in the well. And what happens, you pick up the sample. Okay, you pick up a diluted version of the sample. If you try to re-add that, then everything flows out of the well. In this edition, I'll show you when you're adding the sample what happens if you use the second stage. So I'll go down, 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 add, and then I'll go through the second stage, which injects air and causes the sample to splash out. So now we're ready to load the sample. Now in this example we load one, but in real life you'd load probably 20 samples. Now we're ready to adapt the lid. It's imperative we always follow the color code, so red to red, black to black. Off we go. And then we have the adapters. Again, follow the color code. There we go. Main switch. And then we'll dial up about 100 volts. Okay, so now we're going to take a closer look at what happens when we start electrophoresis. So I'll just turn on the power pack. Observe what happens at the negative pole. You should be able to see a fair amount of gas being evolved, and at the negative we're getting it's electrolysis of water, so we're getting hydrogen formed and oxygen will be formed over here. Now we need to think a little bit about the electricity. From the outlet on the wall we're getting some alternating current. From the power pack we get direct current. So the electron comes out the black lead from the power pack, enters our system, leaves the platinum wire, travels through the electrolyte in the buffer, enters the platinum of the positive side, and then goes back into the circuit. So now we can see the gel is immersed in an electrical field. Our sample has been loaded near the negative. It has a negative charge, so it's actually being repelled by the negative and attracted by the positive. And as they move through the gel matrix, they will separate in order of size, where the smaller ones will move faster than the others, and they will separate accordingly, according to their size. Okay, so we've stopped the electrophoresis to look at the migration of the sample. As you can see, the tracking dyes have left the well. Initially, when you put the sample in the well, you have your glycerol to give it a higher density, so it sinks into the well. You also have colored dyes, and the colored dyes are only there to give you the electrophoretic mobility. It just tells you how far the electrophoresis has progressed, because that's the only visible component in your sample at that time. The DNA or fragments of DNA you are running are invisible to the naked eye, and as they move through the gel, they will intercalate the cybersafe that is within the gel. This way the cybersafe gets concentrated into your DNA strands, and when you take your gel, put it into under UV light, they will become fluorescent, and then you can make you can document your results. So this gel has been set up, and there's an error in the setup, and we'd like to know if you can find the error. Okay, so now we're going to look at the gel documentation system. It's made up of a dark room, which is the bottom part. And in the top part we have the camera. We'll pick up the image from the gel and send it to the computer. As you can see in the dark room, we've already set up our gel. The gel is sitting on top on a glass plate. This bottom part is called a trans-illuminator. It gives UV light. It's going to shine the UV light through the gel, excite the ethidium bromide that's intercalated in your DNA, and make your DNA fragments visible. Now we're going to shut the dark room and activate the system via the computer and pick up the image from the gel. Okay, so now we have the image. You can see the DNA bands are very visible, highly fluorescent relative to the background, and from analysis you can draw your conclusions.